This is the 47 GHz beacon in its plastic enclosure, mounted on a base plate. There is a further weather shield to go over the top of it, which isn't mounted at the moment. It's sitting on a stub mast with its rotator for testing to look at the polar diagram. Down the garden, below the right-hand bedroom window on that house, is the 47 GHz receiver. The S-meter has been set for about mid-scale by attenuating the IF signal, with the beacon looking directly at its receiver. So we'll now rotate the beacon, listening to the audio, and see what sort of attenuation we get. So the signal dropping, going up and down a little, just coming around to 90 degrees off heading. So that's 90 degrees off, and there is background noise and very little indication on the S-meter. We keep coming round about 120 degrees off. Now it's reflecting off the house and off the patio doorpost, and that's about 180 degrees off. We now go back the other way. Some ups and downs in the signal level. Very little S-meter indication, but there's enough audio to be able to find the signal. Gradually coming back to actually look at the receiver. If we just stop here and look at the S-meter, see that we've got much the same reading. We now keep rotating in the other direction. Some nulls. Back to 180 degrees off, where it's reflecting off the metalwork around the patio door. So I've now taken the lid off the beacon box, and we can look at what is inside that makes it tick. So starting from the aerial, the horn is here and is driven by a varactor multiplier which sits in this section here. That's driven at around about 11.7 gigahertz from this amplifier here, which in turn is driven from a ×5 multiplier in this box, which is driven by a synthesizer LMX2541 with an Arduino in the same box, which also does a number of other functions. The reference oscillator is here and was originally boxed, but surprisingly it got hot enough to actually lose its frequency control. So it's been removed from the box and mounted in the way that I normally mount them, where it seems to operate perfectly okay. This is the DC control for setting the OCXO up on frequency. Over here are a number of circuit boards, and we have down here a overall current monitor. Then here is a buck boost regulator so that it will operate for input volts between around 10 and 15 without changing any operating conditions. The output from that feeds a safety regulator for the amplifier, so that's a minimal drop regulator, loses about 350 millivolts. Here is another buck regulator which produces 7.5 volts for the synthesizer and the ×5 multiplier. Over here you just see the back of a Bluetooth module. Needs its top cover to hold it in position. That sends data across to the computer so that when it's all boxed up I can see what the operating conditions are. And there is here a temporary compass requiring replacement as it doesn't have any tilt compensation. So that broadly is what's inside the beacon box.